Hello guys, welcome back to the channel once again. And today we are going to solve this Leetcode question, which is merge in between linked list. It's a pretty easy question to be honest, but we need to take care of some corner cases. And if we take care of those corner cases, then this is the most easiest problem that we can encounter. You know what I mean? Like so, in this question, we are basically given two linked lists of sizes n and m, and we need to remove list nodes from eighth node to bth node and put list 2 in their place. And the blue edges of nodes in the following figure indicate the result. So, I'll just explain you with this. Basically, we're given a list. Let's suppose this is the list. This is the list 1, and we're also given another list which is list 2, and we're given 2 points A and B. So we need to remove all the nodes from 3 to 4 from the list 1, and we need to insert the list 2 from 3 to 4. So if you observe carefully, the third 0, sorry, 1, 2, 3, I'm sorry. The index, I don't know, like they have given the index based on 0th index. So this is 0, 1, 2, and we need to remove the third node till the fourth node. Third and fourth, we need to remove these two, and we need to append this to the another list, right? So the resultant list will be like 10, 1, 13. From 30, it's 2, 3, 10 lakhs, like 1 million, 1 million and 1, 1 million and 2, and 5. It should be like this. It should not be like this. So this is one example, and if you look at this example, we have been given this list, and we have been given this list, and we're given a equals to 2, is 0, 1, 2, and we need to remove from 2 to 5. 2, 3, 4, 5. We need to remove all these nodes, and we need to insert after 1. It should be 1 million, 1 million and 1, 1 million 2. Like this, it should be joined to 6. So, so how are we going to solve this means, I'll explain you with a very easy example. So let's look at this example, guys. And this example, we're basically given two lists, which is list 1 and list 2. And we have been given A as 2 and B as 5. So in this case, what we need to do is we need to identify the second node. It's actually starts from 0th index. So this is the third node. Means this is the first 0th node, first node, second node. From here, I need to remove till 5. I need to remove these, and after this point, this should point to this, and 24 should need to point to 6, right? So this should break. So basically, it should be something like this. This should be gone. This should be gone, and this entire thing should be gone. So it should be like this. So basically, after this, these will not be here, and this will not be here as well. So it will be a single link, single list, which has been inserted in between the list one. So let's see how are we going to do this. Let's see how are we going to do this. So these things have been taught for me by my teacher called Chennakesava Rao sir. He has explained me these things so well that the things that he explained back in BTech first year in my first semester, I still remember the same things right now. He's just a great teacher. And so let's look at this question right now. So I need to remove from 2 to 5, right? So if I need to remove from 2 to 5, what I need to do is, suppose I need to remove this node, right? So in order to remove this, if I have a pointer here, I need to have a pointer here, definitely, right? We should have a pointer here because then only I can break this link. If I'm at this point, I cannot break this link, right? So in order to remove this, my pointer needs to be here. And in order to join this, I also need another pointer here. Let's say this is PTR2. Let's say this is PTR1. And this pointer needs to be connected to this, right? Let's say the name of the node should be as head, and let's say this name of the node is as tail, right? So you might say, how are you going? I'm sorry. How are you getting the names of nodes? We're basically we don't have any nodes, any names for the nodes, but we're going to move the pointer such that these will be placed at these positions, so that it will be easy for us to make the joinings. So this is the entire setup. So we're basically setting every pointer at correct place so that it will be very easy for us to break the links and join new links. So first what I'll do is I'll remove this link and I'll make ptr1.next as head. Right now what I'll do is I'll again take tail.next, sorry, tail.next equals to ptr2.next. So what I'm basically doing is, in the first line what I did was ptr1.next equals to head, right? And in the second step, what I did was tail.next equals to ptr2.next, right? Tail.next equals to ptr2.next. This is what I did. And additionally, we can also do something like ptr2.next equals to null. So we can basically remove these as well. So how am I going to do this? Means ptr2.next equals to null. That's it. If you observe, if you observe, that's it. We don't need to do anything else. You know, when we join this link, this null pointer will also be removed. So this is what we basically need to do. Only three lines. So the major part is moving these pointers to the correct place. It is the most important thing that we have to take care of. If we take care of this, and apply these three lines, then that's it. So how are we going to move these pointers here? So initially what I'll do is, so you might already know we can do this as, you know, we can place this head pointer at this point like with this line, like list node head equals to list 2, right? That's it. So we'll be having my head here, and how am I going to get the tail? How am I going to get the tail means I'll initially initialize my tail with the head, and I'll move my tail till my nodes dot next not equals to null. Initially it is null, right? So I'll move my tail till my tail dot next not equals to null. So the tail will stop here. I hope you understood. And let's rejoin this so that it will be easy for me to explain this. And now what I'm going to do is I need to have a pointer at, I need to remove from 2, right? So I need to have a pointer at 1. So what I need to do is I'll take a pointer here which is ptr1 ptr1 and I'll move how many steps? I need to go to 2, right? So I need to remove 2. So I need to stop at 1. So I only need to move one step, which is a minus 1. A minus 1 steps we need to move. And then I need to go till 5, right? For 5, how many steps? 1, 2, 3, 4, 5. For A, I need to do A minus 1 steps, and for B, I need to do B steps. So my PDR2 will be here. After all these things are set up, we can apply these 2 points and we're basically done. That's it. But there is one thing that we need to take care of. There is one corner case. Let's say they have given something like the minimum A value is 1, right? So the minimum A value is 1. So that means I need to do 1 minus 1 steps, right? 1 minus 1, which is 0 steps. So I'll start from here and I'll stay here, PDR1. And for B, I need to do B steps. Okay. So let's try to code this up. 1 second, I'll be back. Guys, I just looked up, we don't even need to take care of any corner cases. Know what I mean? because if you look at the constraints, the minimum value of a is 1, right? So I thought, what if the minimum value of a is 0? 0 means then we need to remove from here, but they have given something like a is 1, so there is no need to remove the first node, so we don't even need to take care of the base case. So let's try to code this up. So initially we'll be having this head. Let's move this head and tail to the correct points. So list my head equals to list 2, right? This is the list 2's head. And now list node tail equals to, let's say we'll have a function which gives the tail, which moves the tail to the correct point. We'll return list node get tail of list node of head. Now I'll take a pointer, list node pdr equals to head. This is the tail, right? Tail. This is the tail I'm talking about. Initially, it will be initialized from here, and it will move till my tail dot next not equals to null. While my tail dot next not equals to null, my tail will be moving to the next node. And at the end, I'll just return my tail, right? So I have my head, I have my tail. Now I need to move my PDR1 and PDR2. So PDR1 needs to move A minus 1 times, and PDR2 needs to move B times, right? So I'll implement them both in the same function. So this is my PDR1. Move this on the list 1 A times. I'll have PDR2. I'll move this. This should be moved only A minus 1 times, right? The first pointer needs to be moved A minus 1 times, and the second pointer needs to be moved B times. So this will be also moved on list 1, B number of steps, right? So I'm going to implement this node. So now let's implement this list node. This is a list, and we need to move n steps. So what I'll do is I'll take a pointer to list. My I goes till n, and at the end I'll make I plus plus, and till that point my PDR moves to the next node, right? I'll just return PDR. After having all the pointers, so right now we're having all the pointers at the correct place, right? So right now we just need to do these three things. PDR1 dot next equals to head. PDR1 dot next equals to head. And what's the second step? Tail dot next equals to PDR dot next. Tail dot next equals to PDR2 dot next. PDR2 dot next equals to null. PDR2 dot next equals to null. And at the end, I'll just return the list one. So at the end, I'll just return the list one, right? List one will be having the entire connections. So and we'll be removing this. Let's try to run this. It's running fine, and let's try to submit this. It's getting accepted, guys, and that's it. So all the credit goes to my professor called Chennakesava sir. And he's amazing. That's it. And let's look at the time and space complexity. The time complexity is we're basically going from here to here and from here to here once, and we'll be going from here to here once. Let's say the length of this is n and the length of this is m. In the worst case, we'll be going, my second pointer will be going till this point, and the tail will always be going to the n, right? So it will be order of n plus m. It is a time complexity, and if you look at the space complexity, it will always be order of 1, since we are not using any additional data structure such as array list or map or set or any other thing. So that's it guys for this video, and if you find the video helpful, hit the like button. Thank you.